started. Now I take my pen. You take your pen too. You must take your copybooks, and we begin the solution. The first number is find the curvature of the curve at the indicated points. The first number. Write down it. Write the curvature of the curves at the indicated point. And our first curve, b squared x squared plus a squared y squared equals a squared b squared. Each our curves and our point at the point 0, b and a 0. Maybe point 0, b and point n a 0. Good. Maybe in the first divided both parts left and right of our curve by b squared a squared. In this case we can see the known equation. It is equation of ellipse. Look, x squared over a squared plus y squared over b squared equals 1. Basic equation. And if we rewrite it in the parametric coordinates, we will have x equals a times cosine of t, and y is b times sine of t. It is this equation in parametric form. And as I give you in the lecture, in the theoretical part of our classes, I gave you the formula of curvature. K is psi 2 prime phi prime minus psi prime phi 2 prime close our modulus over phi prime squared plus psi, oh sorry, here just bracket, psi prime squared with power 3 over 2, this power. It in polar coordinate. If x is phi of t and y is c of t, yes? It means we must calculate phi prime of t and psi prime of t. Calculate it. Phi prime of t and psi prime of t. Phi prime of t. Phi prime. It is x prime with respect to t. A is constant and derivative of cosine is sine of t. Sine of t. Minus sine, sorry, minus sine. And we will have minus a times sine of t. And psi prime of t is y prime. Psi is b times sine of t. B is constant, write down it, and derivative of sine is just cosine with the sine plus b times cosine of t. And construct a formula for k. K. K is modulus psi 2 prime, 2 prime. Phi 2 prime is minus a cosine of t, yes, and psi 2 prime is minus b sine of t. Good, very good. Then psi 2 prime stay here, minus b times sine of t. Then we have phi prime. Phi prime is minus a times sine of t. Write down it. Minus a times sine of t. Then minus, write down, minus p prime. Good morning, inside Ramzi Rauf. Now I inside Ramzi Rauf. Check you. Yes, good, good. Continue. Minus what I say. Psi prime is b times cosine of t. Write down b times cosine of t. Good. Times phi 2 prime. Phi 2 prime is minus a cosine of t. Minus a cosine of t. Close and close our models. Then our denominator. Phi prime squared. Phi prime is minus a times sine of t. Minus a times sine of t squared. Phi prime squared. Plus psi prime of squared. Psi prime is b times cosine of t. And all of this squared. Close our this bracket and our degree 3 over 2. Good degree equals calculated. Look, minus and minus give us plus. It is plus, minus and minus, it is plus. Then b times a. I just write as a times b. Then sine times sine is sine squared. Then minus and minus is plus. B times A we can write as A times B. Change places. Cosine times cosine is cosine squared. Good. Then here A squared times sine squared. Because squared and for A and for sine and for minus, but minus squared is plus. Plus B squared and cosine squared too. Then our big bracket. Our big bracket and our degree 3/2. In denominator, we can take out bracket A times B under our modulus. A times B times sine squared of t plus cosine squared of t. Close our bracket, close our modulus, and write our denominator. In our denominator stay A squared times sine squared plus B squared times cosine squared. A squared times sine squared, it was what? Plus B squared times cosine squared. See, A squared times sine squared is, we don't know, but good. I think we can rewrite is y over b times a. Y is b times sine. Sine is y over b. Look, sine is y over b. In this, sine is y over b. It means a squared plus times, y over b squared plus b squared times cosine, look, I show you, cosine is x over a, x over a cosine, and it means cosine squared is x over a squared. Close our big bracket, this in, this close, 3/2 with our degree. Okay. And we know that sine squared plus cosine squared is trigonometric unit, equals 1. It means this bracket equals just 1. And a times b times 1 is just a times b. A and b positive because we can not write our modulus. We have only a times b. Then in our denominator we have a squared times y squared over b squared. A squared times y squared over b squared plus b squared times x squared over a squared. B squared times x squared over a squared. And our degree 3 over 2. Then, good. We have a times b in our numerator, in our denominator. In our denominator, we don't have any good way. Maybe we can but why we cannot stay in this? Good, stopped. Maybe we stop in this. Then what we will do? Now we consider our points. The first point M with coordinate 0, b. It means x is 0, y is b. M with coordinate 0, b. And our K curvature in the point M. K as x is 0, y is b. Calculate a times b over all this. A squared times y squared, y is b squared, over b squared, this b squared, plus, not very good, plus, I write it in this place, plus, b squared times x squared, x is 0, 0 squared, 0 squared is very difficult, a squared 3 over 2 equals a times b in the numerator. In the denominator, here b squared over b squared cancel out it. In this we stay a squared. Here 0, 0, 0, 0, 0, 0. And we have a squared with power 3 over 2, 3 over 2. If we calculate degree of degree, we have product. 2 times 3 over 2 is just 3. We have ab over a cubed. 2 and 2 cancel out. Or b over a squared. Clear? Is it clear? Understand?
Yes, yes.
Yes, good. In this case, I give you 5 minutes that you use the point N for calculation, our curvature. You must find K of N. Calculate. I give you 5 minutes. After 5 minutes, I come to you. Yes, 5 minutes for you for calculation. Continue. I think you ended. Yes? Calculate. We must have the answer that right in this place a times b squared. This answer. alpha ig QC, T. Are you here? I don't hear you. Are you here? You ended?
Yes, I'm here.
Yes. You have a times b squared. It is answer. Yes? K of n. A times b squared. This answer in this point.
Yes, yes, yes.
Yes, good. Our next number, it is number 3. Number 2, you must do at home. And we have number 3. Y is x cubed. And any point x first, y first. Y is x cubed. In this case, we have function y of x, and our formula for curvature is modulus of second derivative over 1 plus square root of first derivative, square of first derivative, in the power 3 over 2. And for calculate, in first we must calculate y squared and y prime and y2 prime. Y prime, it is dy over dx. Y prime is y is x cubed. We have x cubed prime. Derivative of x cubed is 3x squared. Y2 prime. Derivative of y prime, or the second derivative, this in the formula. We have derivative of 3x squared, or just 6x. And our k equals modulus of second derivative, 6x in our formula, second derivative, over 1 plus the first derivative, 3x squared. 3x squared, then squared, and power 3 over 2. Good. And we must calculate, maybe I easily it. Equals 6 modulus of x over 1 plus, then 3 squared is 9 squared, without squared, 9, just 9, x squared and squared, x to the power of 4, and power 3 over 2. Yes, good. And at the point x first, y first, we have k at the point x first, y first equals 6 modulus x first, and here 1 plus 9x first to the power of 4 and the power 3 over 2. Good. It is our answer. Next number that we consider, number 5. Number 4, you do at home. At home, number 5 is x with power 3 over 3 or 2 over 3 plus y with power 2 over 3 equals a with power 2 over 3 at the arbitrary points. X with power 2 over 3. Oh, sorry. It's number 5. X with power 2 over 3 plus y power 2 over 3 equals, what is equals? Not. Oh, sorry. Equals what? Equals a to the power of 2 over 3 at arbitrary point. We can find y in this equation, or we can write down it as parametric form. Maybe I show you as you can rewrite it in parametric form. We know that sine squared plus cosine squared equals 1. It means if we divided both parts of this equation by a to the power 2 over 3, and then rewrite it as x over a with power 1 over 3 squared plus y over a with power 1 over 3 squared equals 1. We know that sine squared plus cosine squared equals 1. Look, x usually cosine maybe what z, cosine z squared plus sine z squared equals 1. It means if we denote x over a with power 1 over 3 as cosine of t, for example, and y over a with power 1 over 3 is sine of t, we have right equation. We have right equation. In this case, we have x over a equals cosine cubed of t, and y over a equals sine cubed of t. Or x is a times cosine cubed of t, and y is a times sine, here cubed of t. Continue. And we have parametric form of our equation. X is a times cosine, y is a times sine cubed of t. And as I show you, the formula for k in parametric form have this way. In that we must find phi c2 prime, phi prime, c prime, phi prime, phi 2 prime, all phi it x, c it's y. Here phi of t, here c of t. Calculate phi prime of t is a is constant. Then here we have cosine cubed. It means derivative of the function with the degree 3 equals 3 times function with degree 2. And we must multiply by derivative of our argument. Good. Derivative of cosine is minus sine, and we have minus 3a sine t cosine squared of t. Phi prime. Then phi 2 prime. It is derivative of phi prime. Minus 3a we can write down, and this we have derivative of product. Derivative of product is derivative of the first term times the second term plus the first term without derivative times the second term with derivative. And we have derivative of sine is cosine of t, multiply by the second part without derivative, cosine squared of t. Then plus the first part of our product, sine of t, first terms, times derivative of second term of our product, derivative of cosine squared, in the first derivative of squared 2 times the function with power 1. Power 1 don't write. And we must multiply by derivative of our argument. Derivative of argument of squared cosine is derivative of cosine. Derivative of cosine is minus sine of t. And we have what we have. Minus 3a times cosine cubed of t minus this minus 2 sine 2 part 2 sine squared of t times cosine of t. Good, it is pi 2 prime. We can rewrite it. It is 3a cosine of t. Here cosine squared minus 2 sine squared. This way. Then consider the function y, function c of t. Same way, we have c prime of t. Calculate. We have 3a sine squared of t cosine of t. Same way. C2 prime of t is 3a times 2 sine of t cosine squared of t minus sine cubed of t, or 6, not 6, 3. 3a sine of t times 2 cosine squared of t minus sine squared of t. This. And using our formula for k in the parametric form, I rewrite the formula. K is phi 2 prime of t, p prime of t minus phi c prime of t, phi 2 prime of t, modulus of this, divided by phi prime squared plus c prime squared with power 3 over 2. And calculate using this formula. Calculate using this formula. K equals modulus c2 prime 3a sine of t times 2 cosine squared of t minus sine squared of t times phi prime of t. Phi prime of t is minus 3a sine of t cosine squared of t minus 3a sine of t cosine squared of t. Then minus c prime of t is 3a sine squared times cosine. This t we have is sine squared times cosine of t times phi 2 prime is minus 3a cosine of t times cosine squared minus 2 sine squared. Close our bracket, and all this divided by phi prime of t is minus 3a sine times cosine squared. Minus 3a sine times cosine squared with power 2 plus psi prime. Psi prime is just 3 inside squared cosine. Squared is squared, and all of this with power of 3 over 2. Calculate all of this. What we can have. Modulus. 3a times minus 3a minus 9a squared. This and this minus 9a squared. Then sine times sine is sine squared. And cosine squared, I write down sine squared times cosine squared, and our bracket 2 cosine squared minus sine squared. Then here minus and minus give us plus. 3a times 3a is 9a squared. Then sine squared cosine times cosine is cosine squared. Same here and here, same. And this we have cosine squared minus 2 sine squared. Close our modulus, and all of this divided by here 3a squared is 9a squared minus squared is plus. We have 9a squared. Sine squared, write down sine squared. Cosine squared and squared. 2 times 2 is 4. Plus 3 squared, a squared, 9a squared. Sine squared squared, sine to the power of 4, cosine squared. And don't forget 3 over 2. Then equals here 9a squared sine squared and cosine squared I can take out not only bracket, I can take out modulus, because 9a squared sine squared and cosine squared are the positive values. And I have 9a squared sine squared times cosine squared. And modulus of what? Minus Then 2 cosine squared minus sine squared. With minus, we have minus 2 cosine squared, and minus give us plus sine squared. Minus 2 cosine squared plus sine squared. Yes. Then 9a squared sine squared of t and cosine squared of t. We took out our modulus. And into our modulus, we stay just this bracket plus cosine squared of t minus 2 sine squared of t. Close our modulus, and all of this divided by what we can usually of this bracket. Look, in our bracket, we can see in both of terms of our sum 9a squared, sine squared, and cosine squared exist here and here. And we can take out bracket this expression cosine squared. Into bracket stay. If we take out 9a squared, sine squared, and cosine squared, here cosine with power 4, it means into bracket we stay just cosine squared, because 2 plus 2 is 4, power 4, cosine squared and cosine squared. Plus, we took out 9a squared, sine squared, not 4 squared, and cosine squared. In the bracket, we stay sine squared. And don't forget our degree. 3 over 2. Good. Then, look, cosine squared plus sine squared in our denominator equals 1. This bracket equals 1. Then here minus 2 cosine plus cosine. This was minus cosine squared. Here. This plus sine and minus 2 sine squared. This we have minus sine squared. Then minus cosine squared plus minus sine squared. It will minus 1? Yes, minus 1. Minus cosine squared and minus sine squared is minus 1. Modulus of minus 1, this sum is minus 1. Modulus of minus 1, we have modulus, is just 1. Because we can not write all of this, because times 1 we cannot write. Not we. And we have just 9a squared sine squared of t cosine squared of t in our numerator. And in the denominator we stay 9 is 3 squared, 8 squared, sine squared, cosine squared. Don't forget argument of the trigonometric functions. With power 3 over 2. Now we can consider power 3 over 2 and this power of each multiplier. 3 with power 2 and all of this with power in power 3 over 2. If we find power of power, we can multiply product of this power. 2 times 3 over 2. 2 times 3 over 2 is just 3. And we have, I rewrite our numerator. And in our denominator, we have 3 cubed, a cubed, sine cubed, cosine cubed. 3 cubed, a cubed, sine cubed, cosine cubed. Don't forget argument of sine and cosine. 9 is 3 squared. 3 squared. And we can divide it numerator by denominator, cancel out the second degree of all our function and constant, and we have 1 over. We consider that a greater than 0. In this case, 3 a not maybe I just write down modulus sine times cosine. Or if we don't forget that sine of t times cosine of t equals 1 over 2 sine 2t, we can rewrite it as 2 over 3 modulus a sine 2t. Good. Ended. This number. Maybe I can do export of this on our bracket and then clean our bracket. I post it into chat. Into chat. Good. And in your chat, here exists your board, and then I just cancel out I just clean our board because a lot of information on this board. A lot of information. And we continue. Continue. find the radius of curvature of the following curve in the indicated plot. Draw each curve and construct the appropriate circle of curvature. Number 7, x squared equals 4ay at the point 0, 0. X squared is 4ay. It is number 7, I say yes, 7. Yes, 7. X squared is 4ai. Good. At the point 0, 0. Oh, sorry. I again cancel. Good circle. Where? Here. X squared is 4ai at the point 0, 0. Good. Radius, and we know that radius of curvature equals 1 over curvature. Radius of curvature equals 1 over curvature. It is the formula. It means we must calculate curvature. Maybe I write down it the way 1 plus y prime squared with power 3 over 2 over y2 prime. Modulus of y2 prime. Yes. Just stay in denominator, and in denominator the numerator. Our curve x squared is 4ay. It means y is 1 over 4a times x squared. It's our curve. And y prime find, and y2 prime. Y prime is 1 over 4a. It's constant, just rewrite, and derivative of x squared is very, 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 very difficult to x. And we have 2x over 4a or x over 2a, because 4 over 2 is 2. And y prime, not calculate. 1 over 2a is constant. Yes, derivative of x is just 1. 1. Good. And we can use our formula for r, radius. Radius, sorry, not this radius. Oh, good. Radius 1 over k. It means 1 plus y prime. Y prime is this value, x over 2a. It's y prime, it's all of this squared, and all of this over y2 prime modulus of y2 prime y1 over 2a and calculate at the point 0, 0 we have 1 plus 0 over 2a power 2 over 2 and modulus 1 over 2a. Good. This 0. 1 with power 3 over 2 is just 1, and if we divided 1 by this modulus, we have just modulus of 2a, this way good. And what author of our book want of us, find the radius we find of curvature of the following curve at the indicated point we find. Draw each curve. Yes, we don't draw it. Now we will do it and construct the appropriate circle of curvature. Yes, we do it. We can do it. We have the curve x squared is 4ay. Draw this curve. In this, we must draw. Oh, not very right, but this straight line. Yes. This y-axis, and we have what x squared. Y is x squared. Maybe here x axis. X axis, right. Very good, x axis. And we have what? Y is x squared over 4a. Yes. It's point 0, 0, the first point. Then if x is 1, for example, y is 1 over 4a. X is minus 1, 2. This point and this point. Then if x is plus minus 2, it is a in denominator. These 2 points. Maybe if plus minus 3, 3 squared 9 over 4a, 9 over 4a, 2a, and here well, our curve, we write curve, this curve, we must calculate at the point 0, 0, this point y is x squared over 4a, this point 0, 0. Then radius it's 2a, 2a, here 1 over a, and radius 2a, if a, for example, equals 1, equals 2, we have the circle with this radius, in which radius of curvature here, 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 this circle, or circle of curvature, circle of curvature, this way, very close to the our line that demonstration of our curve y is x squared over 4a, and this circle of curvature, our circle of curvature is radius curvature, modulus a. Clear? Radius of this, yes. No, no. Radius of this curvature is 2a. Good. Very easy. Very easy. Next, our number 9. Y is natural logarithm of x. We must find the radius of curvature of line y is natural logarithm of x at the point 1, 0. Y is natural logarithm of x at the point 1, 0. Number 9. At the point 1, 0. 1, 0. Maybe we do the rest 10 minutes, yes, because we have the rest. And after 10 minutes we will continue. Yes, good. Okay, yes. After 10 means continue. We must construct the circle, find the radius using our formula. So as our last example, we must calculate y prime is 1 over x. Maybe y prime at the point 1, 0. It means x is 1, y is 0. 1 over 1. Very difficult. 1 over 1 is 1. 1 to prime equals derivative of 1 prime or 1 over x or minus 1 over x squared. And if we consider the point 1, 0, if x is 1, we have minus 1 over 1 squared or just minus 1. And this formula 1 plus square of derivative, we spare 3 over 2 over modulus of second derivative. R is 1 plus derivative 1 squared over 2 over modulus of minus 1. Yes, it is very good. 1 plus 1, 1 plus 1, 1 plus 1 is 2. 2 with power 3 over 2, 2 root of 2. Modulus of minus 1 is just 1 because we cannot write down it. And then we must construct our function y is natural logarithm of x at the point 1, 0 and construct the circle of curvature. It is our y-axis, 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 y, and our x-axis. X, natural logarithm of x. Y is natural logarithm of x. If x is, for example, 1 over e, 1 over e, e is the base of natural logarithm. 1 over e. Natural logarithm of 1 over e is minus 1. E approximately 2.7. 1 over e about 1 over 3. If we have 1 in this, approximately 1 over e. Oh, not 1 over e is 1 over e, not on the y-axis. 1 over e minus 1. This 1, 0 And if x is e, 1, 2, 3, e. Y is 1. Y is 1. And we have this line, this line, this line, this line. Y is natural logarithm of x. Maybe blue line, this line. Very, very good. Then our radius 2 root of 2. In this point, we plot the tangent line, and plot perpendicular on this line, perpendicular, and on this perpendicular, we must construct the interval, the length of this interval equals 2 root of 2 radius. 2 root of 2 approximately 1.4 to root of 2, 2.8. It means 2.8. Approximately this radius is 2 root of 2. And we must construct our circle of curvature. I cannot plot circle in this program. Maybe only approximately this whole radius 2 root of 2 and our circle maybe this. Approximately our circle with radius 2 root of 2, our circle. Understand? Clear? Well, definitely that our radius of our circle here in this point perpendicular the tangent line. In this circle of curvature. Circle of curvature. And this center of curvature. Radius 2 root of 2. Perpendicular tangent line. Understand me? Clear? Or not?
Yes, clear.
Clear. Good. It was number 9. Next, number 11. 11. That we consider number 11. Now I find it. Find number 11. 11. Oh, parametric form. X is a cosine cubed. Y is a sine cubed of t. For t is t1. Good. R is 1 over k. Or, in our case, it is pi prime squared plus psi prime squared power 3 over 2 over modulus of psi to prime pi prime minus psi prime pi to prime. Good. It is formula. In our case, this phi, this psi of t. Calculate. Phi prime is derivative of our x. A constant, stay here. Then cubed 3 times function squared and derivative of argument. It means minus sine. Derivative of cosine is minus sine. We have minus 3a sine of t, cosine squared of t. We calculated it in our today class. Phi 2 prime, we have minus 3a times cosine cubed of t times over sine times is cosine minus sine times cosine squared plus minus 2 sine squared plus sine of t. We calculated it later. Phi 2 prime in this calculated. Where maybe I find it here. Here, phi 2 prime. This minus 3a cosine squared minus 2 sine squared. Yes. Then C prime. C prime is y prime on 3a sine squared of c cosine of c, and our second derivative is 3a 2 sine of c times cosine squared of c minus sine cubed of c, or 3a sine of c times 2 cosine squared of c minus sine squared of c. Good. Calculate R using the formula that I wrote down up. Here formula phi prime squared, it is, what is it? 9a squared sine squared cosine to the power of 4. Plus phi prime 9a squared sine 4 cosine squared. Degree over 3a sine 2 cosine squared minus sine squared root times phi prime minus 3a sine cosine squared, then minus 3a sine squared cosine times phi 2 prime minus 3a cosine of c times cosine squared of c minus 2 sine squared of c. Open, and close. Equals 9 a squared sine squared cosine squared in bracket cosine squared plus sine squared degree over here modulus 3a 3a, not 3a, maybe 3 times 3, 9 a squared sine squared cosine squared. Here 2 into bracket we have minus 2 cosine squared plus sine squared. This with this minus, and this minus and minus give us plus cosine squared minus 2 sine squared. It means we have modulus of 1 on here 1 2, here 2 1, and we have sine cubed, sine cubed, modulus 3 squared sine squared cosine squared equals 3a sine cosine. It is our radius at what point? At point M with coordinate T1. 3 over 2 a sine of 2t1. Yes, it is our radius, and we cannot plot it with arbitrary point because we don't know in which point we must plot our circle and tangent line. But maybe we can take any point and plot it in this. Look, our line x is x of c is maybe a is maybe 1. Yes, x of c now I look you. Yes, can you see?
Yes, teacher.
Good. X is a times cosine cubed. Not cosine of c cubed, and y is or not is a times sine. We have a, yes, in our yes, a. What I do y of t. I must plot a times sine cubed of sine of t cubed. I write down our equation. Then in this program I plot the graph in parametric form here. Not want. Plot in parametric form. In this I write down x of t, and in this y of t, and plot it our maybe from -1. Not want. Maybe this very good. And our radius vector that we construct, radius vector, it will what 3a sine times cosine, yes, r of biggest of c is not is 3 times a times sine of c times cosine of c. Yes. And if we take, for example, t is what? Maybe t1 is pi over 4. Maybe this point. T1 is pi over 4. It means r of T1 will be 1.5. This point was in this, and in this we have the line that will tangent line and it x of t1 x of t1 this, y of t1 this. Yes, y of t1 0.5, and in this point we cannot, very difficult. I cannot plot in this program this tangent line. Tangent line is y minus y of t0. It means y First, for example, is tangent line of C equals, equals y0, it is y of C1, then plus derivative of y with respect to x. It means derivative of y and over derivative of x. Yes, times x minus x1 minus x of t1. Yes, it is the equation of our tangent line. Here I must add y1 of t, don't find, y1 of t, x, I know, x1 of t, one of t, equals x of t1 maybe here I stay x, this t1, x is just x, yes, not x1, and I have the tangent line x. So I not want the t1. want plot it. y1 of x want minus function y function just x, maybe not x, maybe not want x, maybe u not want calculate, not very good. Want any yeah. Maybe on t is this will t and this will t. Good. I can be here 1, 2, here 0. It is our graph. Graph of our function. And in this point, we plot the normal line not very good. But this here I cannot copy. Here minus, here x, here y, here t. And plot next line. It's normal line. Here 2. This normal line. Perpendicular line. Good. And this is radius vector in which we must plot the circle. We must plot the circle. Using this radius vector. Understand me or not?
Yeah.
Look, we must plot the curvature circle in the arbitrary point. It is y-axis, x-axis. I draw only first coordinate angle because are the same. This A, and our line approximately this. Not. Maybe I put it this way. Approximately same. Our line. It is x is a cosine cubed t. Y is a sine cubed t. Asteroid. And we have any approximately any point M, arbitrary point, any. In this point we plot tangent line, good, this tangent line. Then normal on tangent line, and on this normal line we draw the interval length r. We calculate in this point, and after it we must plot the circle with this center, and this will curvature circle, full circle. Curvature circle. Next number that we will consider, it is number 30. We come to polar coordinate. 30. It means rho is a times sine of theta. Rho is a times sine of theta. And we have arbitrary points, yes. The formula for calculating curvature of curve in polar coordinate, it is k is rho squared plus 2 rho prime squared minus rho 2 prime over this modulus rho squared plus rho prime squared to the power of 3 over 2. And r is 1 over k. Rho is a times sine of theta. Rho prime. A is constant. We have just a. Derivative of sine of theta with respect to theta is cosine of theta. Cosine of theta. And second derivative, a constant, derivative of cosine minus sine of theta. Then calculate. K is modulus rho squared. Rho is a times sine of theta. Rho squared is a squared times sine squared of theta. Then plus, stay plus 2 rho prime squared. Rho prime is a times cosine of theta. If we have the second degree, we must write down a squared times cosine squared of theta. It is 2 rho prime squared minus rho times rho prime. Rho is a times sine of theta. Times rho 2 prime minus a times sine of theta. Close bracket, close modulus, divided by in our denominator we have rho squared. Rho is a times sine of z. Rho squared is a squared times sine squared of theta plus rho prime squared. Rho prime is a times cosine squared a squared times cosine squared. And all of this have degree 3 over easily. A squared times sine squared minus and minus give us plus, and this will be plus a squared sine double sine squared, and with this a squared plus times sine squared will be 2a squared times sine squared. And 2a squared plus cosine squared of t, just rewrite. Here we can take a squared out bracket. In the bracket stay sine squared of theta plus cosine squared of theta. Close, 3/2. Calculate. In numerator, take 2a squared out bracket. In the denominator, in the bracket, we have trigonometric unit, just one, and a squared with power 3/2. It's a to the power of 2 times 3/2. 2/2 cancel out and stay 3. We just have a cubed. And this here trigonometric unit 2a squared over a cubed. Or just 2 over modulus of a. And k we find r is 1 over k is a over 2. A positive because I can write down without modulus. Look, if we plot this figure, we will have this row axis. Rho is a times sine of theta. It's null, perpendicular. Circle this circle. Maybe blue. In each point, if we will have tangent line, the perpendicular of tangent line come to center of our circle, and the radius will be a over 2. It means our curvature circle equals our circle rho is a times sine of theta. Yes. Next number, it will be 13. Yes, 13. 15. Number 15. What we will have. Number 15. Cardioid. Rho is A times 1 minus cosine of theta. Arbitrary point. Same way. Rho is A times 1 minus cosine of theta. Rho prime. A is constant, just A. 1, 0, minus, cosine minus sine. Minus and minus sine give us just plus sign. And rho 2 prime is A times derivative of sine is cosine of theta. Calculate K. Modulus rho squared plus 2 rho prime squared minus rho 2 prime modulus over rho squared plus rho prime squared to the power of 3 over 2 equals rho squared is a squared times this bracket squared minus 2 rho prime squared 2 times square root of this function, it means a squared sine squared minus here plus, sorry, here plus minus rho is a times 1 minus cosine of theta. It is rho times rho 2 prime a times cosine of theta. Here rho 2 prime modulus over good. Rho squared is a squared times 1 minus cosine theta squared plus rho prime squared. Rho prime is a times cosine, a times sine squared, all of these squared, and the degree 3 over 2 equals calculate modulus a squared open bracket 1 minus 2 cosine plus cosine squared plus I take a squared out because in this term I don't write down a squared. Minus a squared write down, minus open the bracket, cosine theta plus cosine squared. Here a squared, here open bracket, we took a squared out bracket because here we have just sine squared. Good. All of this have degree 3/2 equals a squared. Here what do we want? Cosine plus cosine is 2 cosine. 2 cosine plus 2 sine squared of this squared. It is 2. Just 2 because sine squared plus cosine squared, it is trigonometric unit. Then 2 plus 1 that stay in the first term of our expression will 3. It is 1 cosine squared plus cosine squared is 2 cosine squared plus 2 sine squared is 2, just 2, and 2 plus 1 is 3. Then minus 2 cosine and minus cosine is minus 3 cosine. In the denominator, a squared times cosine squared plus sine squared is 1. 1 plus 1 is 2. All of this degree 3/2. And we have what? A squared times 3 times 1 minus cosine theta. In the denominator we stay a squared and degree 3/2. 2 times 3/2 is 3, just 3, because it we have a cubed. This 2 with power 3/2. It's 2 square root of 2. And 1 minus cosine theta has power 3/2. But 1 minus cosine theta always positive value because cosine never biggest than 1. Never. And we have a squared over a cubed is 1/a. We have 3/2 root of 2 times a. And then 1 minus cosine theta degree 3/2. Here degree 1. 3/2 minus 1 is degree 1/2 because it here square root of 1 minus cosine squared of theta. Or form. Sorry. Y squared, not squared here. My mistake. Not squared. One minus cosine of theta is 2 sine squared of theta over 2. And we have 2 root of 2a square root 2 sine squared theta over 2. It is secondary school formula. Root of 2 and root of 2 is just 2, and we have 3 over 4a. And root of sine squared, it is sine without squared. Please. It means r is 1 over k. It was k, and r will be 4 over 3 a sine theta over 2. And what is it? It is cardioid. Oh, sorry, not very straight line. Cardioid. Maybe here we have approximately. We have any point. In this point we can plot tangent line, plot perpendicular, and our circle this radius on the point M. It is rho is A times cosine 1 minus cosine of theta. Next, our example 17. Yes, it is our last example on this day. Example 17. Oh, a long day today. Example 17. What is it? Parabola a times secant squared of theta over 2. I write down 1 over cosine squared, replace with sine squared. Rho is a over cosine squared of theta over 2. Rho prime, it was times cosine with power minus 2 . a constant, power minus 2. Cosine our function with power without 1 minus 2 minus 1 difference times derivative of cosine. Derivative of cosine is minus sine times derivative of argument of sine is 1 over 2. Minus and minus give us plus, 2 over 2 give us 1, because we will have only sine times cosine cubed. This way. Then the second derivative of rho is derivative of the first derivative, means I forgot a. A times sine of beta over 2 times cosine cube of beta over 2. A constant, then derivative of first term times the second term without derivative plus derivative here minus 3 degree, yes, minus 3. Derivative of second term times this first term without derivative. And we have derivative of sine is cosine times derivative of argument, and the second term just rewrite plus sine just rewrite derivative of cosine to the power of minus 3 in the first power, minus 3 times cosine with power minus 4, minus 3, and minus 1 is minus 4. Beta over 2 times derivative of cosine is minus sine, and derivative of argument of sine, beta over 2, 1 over 2. A. Then maybe I take 1 over 2 out bracket and all. And maybe cosine times cosine to the power of minus 3 is cosine with power minus 2. Then minus and minus give us plus 3. Sine times sine is sine squared over good. Make one denominator and we have not I must take out 2. Good. A over 2 cosine with power of 4. And we have here cosine squared plus 3 sine squared. Oh, good. Very good. It is the second derivative. Yes, the second derivative. And now we calculate k. Modulus rho squared. Rho is a over cosine squared of theta over 2. All of this squared plus 2 rho prime squared. Rho prime, find rho prime. A times sine over cosine cubed. Degree 2 minus rho a times cosine squared times rho to prime. Rho to prime we calculate in this. Yes. Here. A times 2 cosine with power 4 over 2. Good. Modulus of all of this. Modulus of this over what? Rho squared plus rho prime squared. Rho squared a times cosine squared of theta over 2 squared plus rho prime squared. Rho prime is what? Here rho prime a times sine over cosine cube squared and power 3 over 2. Maybe. Good. Equals maybe I take a squared out modulus and we have 1 over cosine with power 4. Two sine squared over cosine with power 6 minus a squared. We take a squared out bracket and we have cosine. What is it? This 2 cosine squared theta over 2 cosine with power 6 minus and plus give us minus 3 sine squared modulus here a squared over cosine power 4 plus a squared times sine sine squared over cosine with power 6. Here a squared got because it in this a squared a times a always a squared. Maybe both part numerator and denominator no. In numerator and denominator we just take one denominator here 2 cosine with power 6 and we have 2 cosine squared of theta over 2 plus 4 2 times 2 sine squared of theta over 2 minus cosine squared of theta over 2. Here minus 2 cosine plus 3 sine y squared. Here not very good. Here minus 2 will minus 2. I mistake the evening. If minus 2 or 2. My mistake. Not all right. 2 because this 4. Cosine squared minus 3 sine squared. Right? I don't mistake. Yes, I don't mistake. All this over 2 cosine to the power of 6 theta over 2 over a squared times cosine theta over 2 plus sine theta over 2 over cosine with power 6. Right? Equals a squared 2 cosine squared minus cosine squared is just cosine squared. 4 sine minus 3 sine plus sine squared. Squared. Yes, squared. over 2 cosine with power 6. What is it? Be up in the first. Write down it. Losses modulus. Yes. Then divided by a squared and degree 3 over 2 is just a cubed. Then cosine squared plus sine squared each 1. Cosine power 6 and 3 over 2. 9. And we have what? Cosine squared plus sine squared, it is 1. A squared and a cubed, here 1. Here cosine with power 3 in numerator, yes, and a squared over a cubed, 2a in denominator. Good. It is k. R is 2a over cosine cubed of theta over 2. Theta over 2. It we find R. We find R in the number 17. At home you will solve all numbers from 1 to 80, and please write down the number that I solved today too.